All right, this week's topic is asteroids and comets. Last week on Friday, you started a worksheet where you did some definitions of these objects, and we talked about them a little bit yesterday as well. So let's go through a couple of definitions. So a comet. On the worksheet, it asked you kind of what they're made of and what their orbital path is. A comet, one of the definitions of the comet is a dirty snowball the size of a mountain. It's made of ice and rock, and one of the things that makes it very different is it has a very elliptical or oval-shaped orbit. And they come from either the Kuiper belt or the Oort cloud. We'll talk about those two things in a minute. But if this right here was the normal orbit of a planet, actually this says Venus, Earth, that's what those are, and then this here would be what the orbit of a comet would look like. They go way out past Pluto, most of them, and then they come really close to the sun. So we could probably even stretch this out even more, in that they go way out past Pluto, around closer to the sun, and it takes a long time. One of the comets, a very famous comet, is called Halley's Comet or Halley's Comet, and it has a period of 79 years. The other interesting thing about comets is they're generally not very solid. And so they're made of rock and ice and dust, but they don't have a really solid surface. So sometimes you'll see on the movies that they'll just go blow them up or whatever, but they're not actually compacted that tightly together. So to actually blow them up doesn't really work very well. So that's what a comet is. As a comet comes closer to the sun, because it is made largely of water, comets are interesting because they have tails. And what the tail is, you see here, so the comets have a tail, which is made of gas and dust and ice or water, because as the comet gets closer to the sun, it melts a little bit. Now you think of the comet as flying like this with the tail out behind it, but you can see from this picture the tail will always point away from the sun. So when the comet's way out here, let's use a different color. When the comet's way out here, it's not melting very much and it doesn't really have much of a tail. And then as it gets closer to the sun, stuff melts and the tail always points away from the sun because the solar wind and the radiation are pushing it away. You actually see two tails. One tail is mostly gases and the other one's the dust and ice. Visibly, you usually can just see one. And so then it's kind of weird because here, the comet is actually traveling this way, although it's pointing this way. And so it would be visible, say Earth is here, it would be visible on both sides of the sun. So you talk about the different parts of the comet. There is kind of a core part here that they call the nucleus or whatever. The coma is this part right in here. And then there's the tails. But really what you need to know, the tails always point away from the sun. It's got a very elongated oval elliptical orbit. And it's made of gas and dust. Questions about comets? That is what you need to know about comets. Yeah, comets always have a tail. And the size of the tail, you can imagine if something melts and we are able to look at the tail, look at the materials in the tail, that tells us a little bit about what the comet's made of, which also tells us about what's out there in the outer solar system past where we can normally travel. All right, so that is comets. Next, we'll talk about asteroids. We've talked about asteroids a fair amount already. Asteroids are too small and irregularly shaped to be a planet. Most of them are found in the asteroid belt. There's more than 100,000 of them then. This is between Mars and Jupiter. Well, we talked before that the idea of where these came from is that either it was a planet that blew up or a planet that never formed. And if you can kind of mathematically take the mass of all the asteroids together, is too small to be a planet. So it wasn't a planet that got smashed. Um, and again, we talked before, the largest of the asteroids are, in fact, bigger than Pluto and rounder than Pluto. And so this is one of the reasons that Pluto got demoted, because there are many other things in the solar system more planet-like than Pluto is. Some asteroids have a very elliptical orbit. They come in closer than the Earth. We were watching that thing yesterday on the Russian meteorite, and because we had the meteorite that passed near, elliptical means oval shaped. Ah, yes, O, like O shaped. I know, isn't that good? So here's the sun, and say here's Earth. So some of the asteroids have a very circular orbit, like a planet, and some of them have a more elliptical orbit. And when we watched that thing yesterday about the asteroid that became a meteorite, and hit over Russia, one of them, so the one we knew about, had a relatively round orbit and was coming in close to Earth. I don't know quite how to draw that. And then the other one had a really elliptical orbit and kind of sneaked in undetected. So it's a little bit weird that it would have that orbit, but some of them do, and then that's why it comes into our atmosphere and gets burned up. Again, we've talked about asteroids quite a bit. The biggest thing is that most of them are really, instead of nice and round, they're really lumpy. And many of the moons of Mars, and Mars's moons and Jupiter's moons, and the moons of the bigger gas giants, a lot of them are clearly captured asteroids, and some of them clearly formed as round spherical planets. And you could tell really just by looking at them. So the question is, how would you know if it's an asteroid or a planet if it is fairly round? And for the most part, part of that definition of a planet is that it is round and spherical. So it would have to be nice and round. The other thing is that it has an orbit around the sun that is pretty spherical. So if it has an oval or elliptical orbit and it's really lumpy, then we're going to call it an asteroid. And mostly also because it's generally quite small. The asteroids are much smaller than the planets. Okay, any other questions about asteroids? Yes. Yeah, Pluto has both an elliptical orbit, and also if you looked at it on its side, if you looked at the solar system on its side, here's the sun right here. All of the other planets kind of go in the same plane, like this. And Pluto has both an elliptical orbit and it kind of goes like this. That's a little bit extreme, but it has a really weird orbit. And we'll talk in a minute where that might have come from. Okay. Yep, on the test there'll be kind of like the fill in the blank, you know, a chunk of rock in space that's irregularly shaped. Or right, exactly, asteroid, or an icy, you know, dirty ice ball with tails. Yeah, so that sort of thing. Those are most. So outside the orbit of Pluto, this is Pluto, lies something called the Kuiper Belt, pronounced Kuiper, and there are many icy asteroid and comet or Pluto-like things. Some of them are bigger than Pluto, some of them are smaller than Pluto, but this is actually what started the whole thing of Pluto being demoted as a planet, because there are so many other things out here that are very much like Pluto. And so if we accept Pluto, then we have to accept all the other things we find as well. Then further out, so this is called the Kuiper Belt, and it actually looks a lot like the orbit of a planet, right? It's not particularly thick. Well, it's thick, but it's kind of like the asteroid belt, only further out. Then there's something else called the Oort cloud. The Oort cloud is past the Kuiper belt, but this is more spherical. Yeah. So it's not just the Kuiper belt is more narrow, like an orbit. The Kuiper belt is kind of, or excuse me, the Oort cloud is kind of in all directions. And this is where it's generally thought that comets come from. And it's really difficult because we haven't explored out there very much. There are two spacecraft, unmanned spacecraft, Voyager 1 and Voyager 2, that in the 70s took beautiful pictures of Jupiter and Saturn. And I believe both of them have both left the solar system and are still sending some signals back. But so from them we get a little bit of information about this. All right, questions about any of that? Yeah, don't worry about Voyager 1 and 2, but they're still sending back some signals. I mean, it's just very slow to get all the way out there. Okay, and then our final topic is a little bit about life on other planets. Okay, so life on other planets, from your worksheets, from your textbook, what things do we know that life needs to survive? What are some of the things that we know that life needs to survive? Okay. Um, yeah, so okay, so we're getting into last year's topics about talking about the 6 characteristics of living things and what living things need to survive. So, yeah, the Goldilocks conditions, because when you look at the inner planets that we've talked about, Mercury is too hot and too cold. It has no atmosphere and really extreme temperatures. So that doesn't work. Then you've got Venus, which is way too hot and the atmosphere is way too thick. Then you've got Earth, which is just right. Yes, it is. And that's why we call it the Goldilocks conditions. And then we've got Mars, where the atmosphere is a little bit too thin and it's a little bit too cold. So what we see here, in order to have liquid water, that's one of the biggest things, is that life as we know it needs liquid water. And so if it's too hot or too cold or not enough atmosphere, that just doesn't exist. So Earth is kind of the right distance from the sun to have this. And the other places that we might think there might be extraterrestrial, and remember we said terrestrial means land or Earth, extraterrestrial life, Mars seems like it may have had life in the past, and the Curiosity rover that's there right now, the main goal of the Curiosity rover is to look for evidence of life. And we started watching a NOVA video that we'll finish on that. Then there are also some moons of Jupiter and Saturn. Europa looks like it may have liquid water. Some of the other ones we talked about, Enceladus, they look like they could have those conditions. And then extrasolar planets, the last thing real quick here, you'll sometimes hear in the news, oh, we found a planet on a distant sun that is Earth-like. All that means, it doesn't mean it's really just like Earth and has life. All that means is it seems to be in a position where it might possibly have these kinds of temperatures. So, and we'll watch a Tim and Moby on that in just a minute. But they make it sound like, oh, we found life, when really it's actually much less definite than that. All right, questions?